So let's work together on problem number 4 in homework 8. I understand we all had the same question and some of the problems are slightly confusing because it doesn't agree with what we have usually denoted in our class. So I just want to clarify it. Well, having 0 or 1 as your answer is quite intuitive. So I want to specify this one and that one. 1 divided by 0 is like what we said in class. For example, if you have limit x goes to 0, 1 over x, you can see the graph goes like this and that. So when you approach to 0, you realize your function goes up to what? Technically, it's going up to infinity, either positive or negative. So the actual representation of d and e is like saying my function, the value of it goes to infinity. So let me write my side notes. If you think something goes to infinity, that's what this problem asked to denote it by d and e. And the other one is I and d. Well, it's used the type 0 over 0 as a representation, and we said a lot of times in class, 0 over 0 means basically it's an inconclusive type of structure. You have no idea what the answer should be. Some further discussion is required. So it's some kind of intermediate formulation. It's not conclusive. It needs a case-by-case discussion. And you probably have tried your homework problem number 3 and number 5, and you might have already noticed based on the formulation, you rephrase them into 0 over 0 type of limit question, which you can use L'Hopital's rule. And quite obviously, your problem 3 and 5, even though both they can be phrased as 0 over 0 type, they have different answers. So that's what I meant by inconclusive. You may end up with different answers. So it needs a case-by-case discussion. So I and D is essentially representing you need to provide further discussion. Well, there are several things we've mentioned are actually not defined. It's a case-by-case discussion. So probably you can still recall them. Some of them are discussed when we first introduced the idea of infinity. And we actually tested the midterm. We said infinity minus infinity is not defined, right? There are similar things, and we remind you about this when we talk about L'Hopital's rule, and that's exactly why we need to do further discussion because those structures are not defined. For example, we don't know what's 0 over 0. We need to discuss it more carefully. Infinity over infinity, we have no idea what's that. 1 times infinity, we don't, sorry, my bad. 0 times infinity, we don't know what's that, so that's why we need to rephrase it and solve it with the help of L'Hopital's rule if that's a type of limit question. And there are some other structures, for example, 0 to the power of 0, and 1 to the power of infinity, and infinity to the power of 0. So essentially what you're looking for are structures which looks like this, which we have discussed in class, telling you that they are case-by-case discussion, so it's inconclusive, and then you can look at other things which you can find the answers. So I'm not going to write down the answer for all of those problems, but I want to help you to get started. So for example, this one in particular, it's 3.14 to the power of infinity. Think about it, 3.14 and keep multiplying itself. It's just gonna keep getting larger and larger and larger. So when you do it many times, you definitely goes to infinity. And like I said, infinity, you denote it as D and E following the notation requirement of this problem, right? So we end up with D and E. 1 times infinity is essentially infinity, so we go with D and E, right? 1 to the power of infinity, which is something we said already, it's really not clearly defined, so it's an intermediate structure where more discussion is required. Infinity minus infinity is something we said, okay, it's an intermediate structure. You want to do the discussion more carefully yourself. Like I said, I'm not going to solve all the problems. For example, this one, if you look at it, it's infinity to the power of infinity, 1 divided by that. Infinity to the infinity is still infinity, 1 over infinity is 0. So this problem in particular, it's actually 0. it is actually 0, right? And also, for example, something like this, it's 1 divided by infinity. It's essentially 0, but it's negative of 0. Well, negative of 0 is still 0. So that's what we end up with. That particular problem we have there, it is supposed to be 0, right? And 1 to the power of 0, for any non-zero number to the power of 0, it is actually 1. So this one here in particular, it is 1. So I encourage you to do this type of discussion yourself. For example, this one, it is 1 to the infinity and 1 over that, because the denominator is like what we said earlier, it's indeterminate. So 1 divided by that is also indeterminate. So I end up with I and D here. And just to take one more as an example, we said 0 to the 0 is indeterminate, right? So try to do the same discussion, and now you understand the meaning of I and D, which means you have a lot of case-by-case discussions. What did I say? Case-by-case discussion, right? And where D and E represent infinity, and you may have some other numbers, 0 and 1, coming out as the answer. So try to finish the discussion yourself and identify them. I've listed pretty much all the cases where you will end up with the IND. So just make sure you translate the problem you run into to look like something, to something that looks like this, so you understand whether it's intermediate or not. To find it being 0 or infinity, hopefully it's more intuitive. And don't forget, we denote that as D and E when you run into infinity cases.